Me and Jeremy, we had made hot ice. Our hypothesis was if we touch the cool heated sodium acetate, then it should react. Our problem was how can we make a substance hot that is normally cold. Our background information is that it is an exothermic process, and so there will be a lot of heat, and so it will solidify quickly. The formula for it is H2CO3 plus NaHCO3 yields NaC2H3O2, and if we add the baking soda to the soda water too fast, it will act like a model volcano and explode. And the materials you will need for this is a spoon, a medium saucepan, a stove, 1 liter of soda water, 4 tablespoons of baking soda, an open and closed container, and also a refrigerator. Our procedure for this was we put the soda water in with the baking soda into the saucepan. We heated it and for about 60 minutes until there was 100 milliliters left, and then we put the solution into the 2 containers, the open and closed one, and we put it in the refrigerator. Our analysis is when we boiled the baking soda and soda water, the top of the saucepan turned white. The more we heated it, the more it evaporated and condensed. After 15 minutes, we had started our observations, and the solution was boiling, and it didn't look like there was less. We had needed to stir the solution more though to mix it up throughout our observations, and we stirred continuously. At 30 minutes, there was a little bit less of the solution, and then we had started out with, and at 45 minutes there was a lot less, and the top of the saucepan was completely white. And at 60 minutes, there was almost no liquid left except for the 100 milliliters of the solution we needed. After that, we had put the solution into the freezer, and it turned into a solid substance. When we put a crystal into the solution to react, nothing happened. That happened to the closed container and the open container. And when we put the substance into the refrigerator, it had turned into a slush, and there was no difference between the open and the closed container. And for our conclusion, if we touch the cool heated sodium acetate, then it should react. Since our experiment didn't work several times, we're going to reject this hypothesis because we used soda water and not vinegar, and our experiment didn't work because the soda water and the vinegar have similar properties, but they don't have the exact same for the experiment to work. And because vinegar is more acidic than the soda water that is mostly carbonated, and to work this experiment, we had needed an acidic liquid.
Okay, I want to show you our data. After 10 minutes, it boiled. You can see it there. It was 10 minutes, but there was a lot of condensation and evaporation, and the top turned a little bit white. Then after 30 minutes, there was a lot less liquid because you boiled it for 30 minutes. And the top was really white already, and it was still boiling. After 45 minutes, there was almost no liquid left. You can see it up there, and it was still boiling, and the top was white. After 60 minutes, there was like almost none liquid left. We had like a little bit liquid, that much that we needed, and the top was really white. It was like snow, and yeah, when we put our stuff into the fridge and the freezer, nothing happened. We put it covered and uncovered in there, but somehow it didn't work. So our limitation were like they said on the website, we should heat it slow, but that's what we did. Maybe we should have heated it faster, and our saucepan could have been a little bit dirty, but I don't know. And maybe we should have cleaned it. Our temperature in our fridge could be a little bit too low or too high. Maybe it wasn't perfect. Like we had to be around the freezing point of our substance. Maybe it was too low or too high. And next time, we should make sure everything is clean. Then we should maybe use a controlled temperature for our stove and our fridge. And we should definitely use acidic liquid like Coke or Pepsi or Sprite or whatever, not soda water. And yeah, hand warmers are related to this experiment because it's basically the same thing. You freeze it, it gets cold, you push it, and it turns hot. And yeah, that's basically all the limitations. What does it have to do with chemistry? First, when we mixed the stuff together, we made a solution, and that's first chemistry concept. Like it's a chemical reaction. Then when we boiled it, water went away, so we split it again, and that's another the solution. So that's another chemical reaction. Then another one was the temperature. When we heated it, it's the particles move way faster, and that's another chemical concept. And when we put it in the fridge, it cooled down, and yeah, the particles went really slow because it almost froze and it crystallized. Yeah, our resources were chemistrydaily.com and chemistryabought.com, and I did it with West, and that's our chemistry project.